Hello everybody, welcome to my channel. Today we have a very good problem for you guys called evaluate reverse policy notation, right? This is a very good problem, so pay close attention to the problem statement, right? So it says, given an array of strings, tokens, right, that represent an arithmetic expression in a reverse policy notation. Evaluate the expression, return an integer that represents the value of the expression, all right? So we have a note here, so the value operators are plus, minus, multiplication, and division, right? So he said each operand may be an integer or another expression, right? So the division between two integers always truncate towards zero, okay? There will not be any division by zero. E will represent a valid arithmetic expression and reverse policy notation, right? Okay, that's good to know. The answer in all the intermediate calculations can be represented in a 32-bit integer. So pretty solid. So yeah. So we're given this, like they said, right, this array of tokens, right, which represent the reverse policy notation, right? And this is what they mean by that, right? And our job is to evaluate that, right, and return a single integer value that represents the calculations in this particular one, right? So for example, right, this one, that's the explanation, right? So we have 2, 1, right, plus 3 multiplication, right? It might look confusing at first because we're not used to it looking like that, right? And also the corresponding representation of the way we're used to it, right, is 2 plus 1, right, times 3. So that's exactly what this represents, right? So that's kind of our answer, right? This is what it's called, the reverse policy notation, right? That's kind of what it is, okay? Yeah, so that's kind of how they do it, right? So you can see that, they have the operand, right, after the numbers that it should apply to, right? So we have a plus, right, which means to add those two numbers, right, which is 2 plus 1, and then we have a 3, and then we have a star, right, which means that to multiply 3 with the previous number that was before, right, which is this one, right? So previous number is 2 plus 3, which is 3. 3 times 3 equals 9, right? So that's kind of what it is, right? Pretty simple as that. Let's go another example to make it easy for you guys. So we have for 4, we have this one, 13. We have 4. We see a 13 or 5, right? So we see operand. Operand means just get the two last numbers, right? Which is 13 divided by 5, right? Then it gives you a plus here, right? Okay. Simple as that, right? Okay. Yeah, so we see a 13, 5, we divide, right? Yeah, right? Which whatever it is, right? Probably give you like 2 something, right? And then it's 4. Then we see a plus, right? And this plus means whenever this thing, right, equal to plus 2 equals 6. That's kind of how we got 6, right? So this is how it is. They explain it here. Oh, this token is kind of long, right? So pretty much you kind of get the gist, right? Pretty simple, right? So you see this, the way of doing the arithmetic, right, is very similar to how we do the regular ones, right? But the only caveat here, right, is that whenever we see the operand after the numbers that it should apply to. Okay. So what I'm thinking here and doing, right, what we could do is to go ahead and start doing it like we know of, right? So pretty simple, right? So how can we do it, right? So we need a way to like store the numbers, right? So we would we add 2 to our number. Let's say we have a pile of numbers, right? And then we just adding the numbers, right? And then once we encounter an operand, we go ahead and get those 2 numbers. We do whatever the operand said that we need to do, right? And then we put 3, right, in our thing, right? So because we need to keep track of the output result of that, right? Because it might be useful for other calculations, right? So we add that, and then we keep adding numbers, right? 3. Then we see an operand, right? Then we go ahead and multiply. We do whatever the operand says to do, right? We get the last 2 numbers that we have in our pile, right? And then we multiply them like that, right? And then we get a particular answer, right? So that's kind of the main takeaway here, right? Just to do this particular problem, right, is to add our numbers in some sort of a structure, right? And as soon as we encounter an operand, we get the last 2 numbers in our structure, then we add it, right? And then we do it and then do the operation, right? and then we add the result back into it, right? So that it can, do the calculation, right? So that's kind of how it is, right? So this structure that I'm talking about, right? The light bulb should be going on in your head that the structure that kind of fits the bill for this one, right, is a stack data structure, right? Because it fits the last in, first out, right? Because at any given point, right, we want the most two recent numbers that we've seen, right? As we loop through the array from left, the string from the array from left to right, right? We get the last two numbers, and whenever we need to get the last number that we've added, right, the stack is the data structure of choice for this kind of problem, right? The Q wouldn't be as useful here because we don't want the the things from the beginner, first in, first out, right? We want the last ones that we added. That's why the stack is perfect for this particular problem, right? Because it allows us to do those operations, right? Okay. So yeah, so that's kind of how it is, right? So now there's one issue here, right? Yeah, no, right? So that's kind of how it is. Okay. So we could even do this example just to kind of help bring the point home, right? So we have the stack, right? We have a 4, we see a 4, and then we see a 13, right? Then we encounter the operation, right? Oh, we see a 5, right? And we see an operator, right? The operator says to divide the last two numbers, right? Then we do boom, boom. We do, we get the last number, which is 5. We let's call it num1. So one thing that we need to do here, right? We'll follow this example, which is where we do num1 minus we'll do num1 plus whatever the operator is, right? Operator. Num2, right? Num2 is the number that's at the top of this thing, right? So let's call that the top of the stack, right? Because that's the number to the right of the operand, right? That we have. Okay. So now num2 is 5 for this case, right? And then num1 is 13, right? Okay. So now that we have that, right? So now we do the operand just like that, right? Num1 is 13 divided by 5, right? It's not 5 divided by 13. So the order really, really matters. And thinking, doing the operations like this manner, right, will kind of help us to catch those cases, right? Or those division and subtraction, right? Those are like special cases, right? They're not as easy as the addition and multiplication, right? I think there's a word for it that I can't really come up with it right now. That 4 plus 7, right, is the same as 7 plus 4, right? But for subtraction, right, 10 minus 3 is not the same as 3 minus 10, right? Which is just different here, right? Cool. So this is to handle those particular cases. Yeah. So we have 5 to 13 here, okay? So now for this particular case, right, it's 13 minus 5. No, 13 divided by 5, right? Which gives us the 2 point something, right? It doesn't matter since we truncate the decimal for divisions, right? That's what they said to make it easy on us, right? So we go ahead and do this operation, and then we see a 2, right? Okay. And then we see a plus, right? And the plus says, num2 is 2. Num1 is 4, right? It doesn't matter because it's the same thing, right? So we end up returning 6, guys, right? So it's as simple as that, right? I think the code will be a lot simpler for you guys to understand. The tricky part of it was the subtraction and division case that we need to handle here, right? But yeah, so it's let's quickly go ahead and do it, guys, right? So we said we're gonna use a stack structure. Let's do an integer, right? S for the new stack. Okay, so now we're gonna loop through the stack, guys, right? We're gonna do string token and tokens, right? Yeah, so that now that we have that, right, we're gonna loop through. So we're gonna build a function here real quick called is it an operator or not, right? We're gonna pass it in here. going to pass in a string op if, let's call it token, a return token equals to plus or token equals to minus, or all the different pretty much so it's multiplication and division, right? So let's just copy this real quick. It's kind of slow. Or division. Okay. So this handy function is going to be very useful, right? So as we go here, right? So if is operator, is operator, right? Token, if it's an operator, then we'll enter here, right? Okay. So now that we have this, right? So we're gonna get the first number of the stack, right? Which is, because I said we're processing the always the last two numbers, right? So the number 2, right? Because that's the number to the right of the operator, right? It's very important that you guys get this particular concept here, right? So number 2 is the thing at the top of the stack. Okay. And num 1 is the next number, right? Okay. So now we're gonna pretty much do the operation here, guys, right? So we go ahead and do whatever the operator says, right? So if the token, right, which is, we know it's an operator at that point, right, is equal to a plus, right? Also, other cases where it's equal to a minus, and also other cases as well. So we'll handle all of them, right? So we have our plus, then the minus, then the multiplication, and we're gonna have our division here, guys, right? So what we're gonna do is to the result is equal to, for plus, right, num1 plus num2, right? Okay. After that is the num1 minus, right, for subtraction. This one is multiplication, right? And this one is the division, right? Because we've handled that tricky case, right? By popping it in that order and naming them accordingly, right? And having our t-sheet here just to understand the flow of it, right? Which one, right? Okay, it looks good to me. Let's go ahead now and do the handle the case where it's not a operand, right? So what we end up doing is to just push whatever that number is, right? So integer, that value of, right? Percent, doesn't matter. So we just go ahead and push it on there. So push the token in there, right? And then at the end, we simply return as that pop, right? We always have a valid one, so we're good to go, right? Yeah, so let's quick recap. So just have we have our tokens, right? We loop through our tokens and then we check if it's an operator. If it's an operator, we go ahead and apply those operations, right? The operation will be applied on the last two numbers that were added in our stack, right? And that's how we're able to easily do that, right? And we pop it in this manner, right? The first number at the top of the stack is the second number to the right of the operand, and the first number 1 is the number to the left of the operand, right? Operator, right? And then we have a token, and then we go ahead and apply those in this manner, right? So it's kind of visually good here. And then we add that number. If it's a number, we add it to the stack, right? So that can be used later on. So let's press okay. Oh yeah, I see what I'm doing. So in Java, it's like that we need to use the equals, right? So anyway, I'm doing this for all of the there real quick. Now it should be good. Let's press run now.
Bruh.
Oh yeah, so remember that for the result, right, we need to push the result into the stack, right? After we do the operation, right? It's very, very important that you guys do
Bruh.
that. So we push the result. So now we also need to make sure that we use the equals. Keep forgetting that particular case. So let's just do equals, right? So that's kind of the whole flow, guys, right? Now we check percent operator, then we apply the operand, right? And then do that, right? We store the result, right, for future iterations here. So let's press run. Looks good. Everything passes. Press submit. Awesome, guys. We're able to pass all the test cases, guys, right? So this is a very good problem. As you can see, it's very, very unique, right? So this is a very good introductory question to stack problems. If you guys really enjoyed this problem, and you guys understood the thought process, in the comment section. If you're new here, subscribe, because we'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next video.